You need to listen to this carefully because what scientists have just confirmed in Japan is not something small. It's a giant caldera volcano. Giant. And if we hear caldera volcano, we're thinking maybe Campi Flegrei 2.0 or even something worse, because this, what we're talking about right now, is the same system that produced the largest eruption of the entire Holocene. That's our epoch right now. And this is why I'm making this video. Now something is happening there, guys, that is not good, because it is refilling again. It's refilling with magma again after 7,300 years. Let that sink in. And yes, if you follow my channel, if you follow what's happening with the supervolcano Campi Flegrei in Naples, Italy, you know that matters. It matters a lot, because when we talk about a caldera volcano, we're not talking about a normal eruption. We're talking about events so powerful that they can reshape regions, oceans, the world, the climate. So that specific system that I'm talking about is the Kikai Caldera in Japan. And about 7,300 years ago, it produced what is believed to be the most powerful eruption of our current geological epoch. Almost the entire magma reservoir was emptied in that massive event. Hundreds of cubic kilometers of material, poof, out and gone. And then the ground collapsed because that big magma chamber underneath the surface was now empty. That has formed the massive caldera that we see today. And for thousands of years, everyone thought, the scientists assumed, that system was essentially quiet. But what do I always say? Assumptions can kill. So now, new research has surfaced, and it shows something very, very different, unfortunately. The magma reservoir is filling up again. And this is the key part. The exact place that I'm talking about right now is the Kikai Caldera. I mentioned that. The location is just south of Kyushu in southwestern Japan, just south of the Ryukyu Islands. We know the Ryukyu Trench, right? We're talking about Japan a lot with big megathrust earthquakes. So in the northern part of the Ryukyu volcanic arc. And we know if we have big dangerous subduction zones, we do have the volcanoes. We do. And most people do not realize that this volcano is mostly underwater, so you don't even see it. It's basically mostly what we call a submarine caldera. It's about 15 miles wide, roughly 20 kilometers, and we have the Satsuma Iwo Jima sitting on the northwestern rim. And the best known active cone there is called Lodake. So the Japan Meteorological Agency lists Lodake at an elevation of 704 meters. So that's more than half a mile. And I'm telling you, you will see why. That alone changes the whole feeling of what I'm about to tell you, because this is not some cone that is standing in plain sight where like everybody can watch every change on the slopes of it. A huge part of this system is completely hidden beneath the sea. So with a bare eye, we cannot see what's going on there. And this is some reason, or one of the reasons, why scientists have said for years that they were really poorly equipped to understand how these giant caldera systems recharge after a major eruption. So the underwater setting is basically also why researchers have used large marine seismic surveys with airgun arrays and ocean bottom seismometers to imagine what's happening below it. They needed to find out. And now let me explain why this volcano exists there in the first place before we get to what they really found and what exactly is happening there, because this is where the story gets really serious, guys. Kikai is part of the Ryukyu arc. This is a long subduction zone system. On this channel, we're talking about it on a regular basis when it comes to earthquakes, right? The Philippine Sea Plate is being driven beneath the overriding plate along the Ryukyu Trench, and this whole, it's called an back arc region, has also been undergoing extension on its back arc side. That means, in simple words, one plate is diving down, fluids are being squeezed out of that slab, and then those fluids rise into the metal wedge above. And that helps generate melt, is magma, right? Which can then work its way upwards into the crust. And then it can feed volcanoes like the Kikai volcano. And the new research is important because it does not just say, well, there's magma somewhere down there. It actually images a broad, low velocity zone under the caldera from the crust down roughly at 30 kilometers depth, roughly 22 miles depth. And then at roughly 10 kilometers depth, roughly like 6 to 7 miles deep, the signal that they're getting and the multiple signals that they got suggest that there is, how we call it, volatile rich material. Basically, that means fluids are rising upwards from deeper magma. And that's never good if we're talking about a volcano, right? And then they found deeper down at a depth of roughly 20 to 25 kilometers, like 15 to 20 miles. They imaged deep magma reservoirs in the lower crust. Bang, boof, there is it. But they also found another possible deep magma body at about 20 kilometers, 70 miles northeast of the caldera center, at a depth of roughly 15 to 20 kilometers, like 12 to 17 miles. So this is not one tiny pocket of melt or magma, one little magma chamber. No, it's several spots, and that's only the ones they found. So it looks like what we're dealing with here at the volcano, it's like a multi-level plumbing system, something similar to Campi Flegrei. We have several magma reservoirs at different depths and in different locations. And that's the part that people really need to understand. Giant caldera volcanoes are not just one crater with some magma underneath, like a stratovolcano or something. They're systems. They're sources for deep melt, for deep magma, for fluids rising, for reservoirs that are forming and that are existing in the lower crust, and with pathways into the upper crust. And then sometimes a shallow body of magma is capable of feeding renewed activity. So the Kobe University in Japan says is that the magma reservoir directly beneath the volcano that erupted 7,300 years ago is there again. It's there again. I want to make this clear. And because of its extent and location, they say it is clearly the same reservoir as the one that was involved in the previous giant eruption. So if that is refilling again, if you watch my channel and you've seen the Iceland eruptions, that's a small, tiny worm compared to this. But eruption, it's refilling, reaches the point again where it has maximum pressure, and poof, we have the next eruption, right? But here, there's one detail that makes it even more fascinating, so you need to hear this. But before you do, can you please like and hype this video? It helps my channel, doesn't cost you anything. Thanks so much. So scientists do not think this is just a leftover magma from the last eruption, which would kind of be better, don't you think? So it's not somehow that magma sat there since the last catastrophe. Nope. In the center of the caldera, there's a new lava dome that has been forming, not just recently, it's been going on for quite a while, and that makes it so concerning. Has been forming for 3,900 years. I have to say it again, poof, let that sink in. And the chemistry of that more recent material differs from what erupted in the giant Kikai-Akahoya event. That means, guys, the magma that is now present is newly injected magma. It comes from a deeper source down there, and it's new. It's not the old one. And again, I say it in other words. The system did not just survive. It started rebuilding. And that's exactly why the scientists care so much about this, and that's why we should care about this. Giant caldera eruptions do not mean that a volcano is finished forever. They can reset the system, and then, over very long timescales, magma begins to accumulate again. So scientific work near the Kikai Caldera already showed that after an older catastrophic eruption about 95,000 years ago, the magma recharge and magma restorage continued for tens of thousands of years before the next catastrophic eruption, the one that happened 7,300 years ago. So Kikai's history is basically telling us these are long cycle systems that can rebuild and are rebuilding right now after devastation. So now let's talk earthquakes. What can this produce? Because if something's filling up underground, you know that from Campi Flegrei, we see earthquakes. And with a place like this, of course you do not just watch for an eruption. We've learned that if you watch on a regular basis. That's why you should subscribe. Thanks for that. You watch for earthquakes, right? There are several earthquake environments here, and they are not all the same. I want to say that also. First, of course, right around the volcanic system itself, you can get shallow volcanic earthquakes. The kind that is tied to cracking rock, that if something lifts up, if you blow a balloon underground, the rocks are cracking, right? We have moving fluids, we have pressure changes, we have hydrothermal activity, we have magma shifting, of course, right? And the monitoring that they are doing has documented volcanic earthquakes around Satsuma, Lojima. We have ash emissions, strong fumarolic activity, and even earthquake swarms before eruptive activity. We have the 1934-35 submarine eruption there east of the island that created Showa Lojima, for example. And then there's deeper low frequency earthquakes and deeper volcanic signals. So the research shows that on Satsuma Lojima, it shows both shallow earthquakes and deep low frequency earthquakes in the monitored systems. So those deeper low frequency events matter a lot because they can be associated with fluid movement at depth, which is exactly the kind of thing, the kind of pattern that scientists pay attention to in active volcanic plumbing systems. And then third, below the volcanic arc, there are intra-slab earthquakes inside the subducting plate, of course. So this new tomography study says that the mantle wedge low velocity zone sits just above the area where intra-slab earthquakes are active, and it links those earthquakes to dehydration, embrittlement in the slab. That is basically as the slab goes down in the subduction zone, the minerals release water, and that helps to trigger earthquakes in the descending plate. And then those same fluids may help the partial melting that ultimately feeds volcanism above. So the earthquakes and the volcano, they're not the same thing, but they are part of the same tectonic machine. And then, of course, we have the broader regional hazard, the Ryukyu Trench itself, of course, right? This is a major subduction zone with high seismicity, and research on the Ryukyu system shows it can host slow earthquakes, low frequency earthquakes, tsunami-genic events like earthquakes that produce a tsunami. Japan knows a lot about that. And also potentially very large subduction zone earthquakes, megathrust earthquakes in some sectors of the Ryukyu Trench. So that does not mean that Kikai's magma refill is about to trigger a gigantic megathrust quake. There is no evidence for that right now, but it does mean that this volcano sits inside a region where strong tectonic earthquakes and tsunami hazards are already part of the big background danger. So what could actually happen there? What am I talking about, right? So the first thing to say clearly is the new study does not mean that there's a giant eruption imminent. The scientists do tell us that the reservoir is refilling and has been for quite some time. It doesn't say that we have a super eruption that is around the corner. And that distinction matters, of course, right? But it does mean the system is alive, it's active, and it's rebuilding. And that can already cause a lot of trouble for us right now. And once you know that this is happening there, several scenarios matter, right? The smaller scale scenarios are the most realistic right now in the near term. So increased earthquake swarms, stronger gas releases, more vigorous hydrothermal activity. We can see discolored water. We can see explosive activity at Lodake. We can have renewed submarine eruptions. We can have dome-related unrest in and around the caldera. So a lot of stuff can happen there. So those are all consistent with the fact that Kikai and Satsuma, Lojima have had recent eruptive and fumarolic activity. We've seen intermittent white gas and steam plumes, discolored water, and earthquakes in modern monitoring records. We see it. But the long-term reason, and this matters much bigger. If magma continues to be injected and stored over long periods of time, then the system could continue growing towards future large eruptive potential. So Japan has it everywhere, on land, in the water. So we could see an eruption, a collapse, and another recharge, again, another rebuild. And Kikai is one of the clearest places on Earth where scientists are now watching that rebuilding process happen. That's the interesting part. And do not forget what this volcano has already done. So the Japanese Meteorological Agency, their catalog lists the eruption 7,300 years ago, the Kikai Caldera eruption, on the volcanic activity scale VEI as a 7, with airfall tephra, pyroclastic surges, pyroclastic flows, and work that was concluded in 2024 from the Kobe University concluded it was the largest volcanic eruption of the Holocene by far. So when scientists say the same reservoir is being recharged by new magma, this is why we have to pay attention. Not because disaster is guaranteed right now, right? But because that monstrosity of a volcano that is responsible for the most extreme eruptions of the last 11,700 years is not dead, it's alive. So that's not just some underwater crater that lies south of Japan. It sits on one of the planet's great tectonic boundaries. It's fed by subduction. It has a deep and complex magma plumbing system. It already shows earthquakes, volcanic seismicity, deep low frequency events, and it sits above this intra-slab earthquake zone. And now we have this strong evidence that the giant magma reservoir that is tied to its last catastrophic eruption is being refilled with new magma, the same reservoir, not something new that has built where we don't know what that might do, right? So do not panic, but this absolutely means this is one of the most important volcanoes on Earth that we need to watch now. I hope you like this. If you want to know what the other important volcanoes do, check out my Campi Flegrei videos. I have a playlist, really interesting, Naples with more than 6 million people. But something's falling from the sky. These meteors keep falling every day. I experienced one, and the sonic boom really scared me. I'm used to jets breaking the sound barrier and stuff like this. I've heard earthquakes. When I heard this, I thought, is the big megathrust earthquake at the Cascadia Fault happening. It felt intense. I felt it in my body, like sitting next to a subwoofer. It was really scary. And now they're coming everywhere, all over the world. It's really intense right now. Can we still call that normal? The video's in the end screen. Thanks so much. If you want to support the channel, link is in the end screen, or click the join button. Thanks for you supers, and thanks for everyone who's giving me this continuous support. You guys are awesome. Hey, click this. See you here.